Neha. Pradhiman, Pradhiman, you had exams yesterday, what?
Yes, sir.
Which school, Shala?
Sir, I'm shit.
Oh, and this chapter was there yesterday itself.
Yes,
What?
sir.
Yes,
Yes,
sir.
sir.
Why did we keep the session today? It is told to you all also, isn't it, that you have a session? Which batch you all are from?
Red House.
Red House.
Purple.
Oh my God. And yesterday you all had the exams?
Yes.
Yes, sir.
Oh God. So the exams are done for this?
Yes, sir.
Yes, sir.
How was the paper?
Good, sir.
Mostly theoretical.
Mostly?
Theoretical.
Mostly theoretical.
Yeah,
Okay,
less
then from
numericals.
okay, but rotational का पूछा था? Rotational का बहुत सारा पूछा
सर
था.
यही एक आप जो पढ़ा रहे हो ना एक्सिस ऑफ रोटेशन ये भी आया था एक
सर असर्शन वो रीजन में आया था.
अच्छा, किस रीजन में आया था? और फिर इसके बाद वाले में कहाँ पे पैरेलल एक्सिस, परपेंडिकुलर एक्सिस पूछा था?
सर इतना नहीं पूछा था सिर्फ एक्सिस ऑफ रोटेशन का एक पूछा था
नॉर्मली था, इतना हाई नहीं पूछा.
Okay, fine. Oh my God, then why did they keep it sessions today? They should have kept it day before yesterday, whatever it is. They should have taken. Even the schedule was given to you for today only, isn't there, students?
Yes.
Fine, doesn't matter, students. We'll wind it up, students. Okay, we'll finish it up. Doesn't matter. Okay, we'll do it as fast as possible.
Welcome
हो
everyone.
जाएगा,
We are
we'll
live
do it.
the second episode of rotational motion.
Pardon? I can't hear you. Who's this? Who was that? Ruti. Okay. Shall we continue further, right?
Yes, sir.
Okay, fine. Students, हम लोग tangential acceleration अगर लेते हैं students, तो tangential acceleration का formula क्या होगा? First particle का r1 होगा, alpha होगा. It won't be alpha 1 because alpha is constant. अगर entire body rotate होता है in an anti-clockwise direction, students, tangential हम सारे y-axis पे होंगे, angular terms z-axis पे होगा, perpendicular to the plane. What is acceleration for the second particle? Will be r2 into alpha. This will be rn into alpha. What about the corresponding force? What is the corresponding force? Then how do you go about it? So force is given by the formula mass into acceleration. So देखो m1 a1 I. This will be what? m2 a2, and this will be m and a. Now when I go for torque, what exactly the torque I'll consider will be? Torque acting on the first particle, torque acting on the second particle. Can I add all the torque to get the net torque? Why not? So when I want to go for the net torque, add the torque for all the constituent particles. Students, so torque for the first particle will be equal to what? R cross F. Students, it's R cross F. So it will be R1 into F1. So can I say it's M1A1 plus torque for the second one we consider is what? R2 into M2 into A2. Torque for nth particle will be what? Rn into Mn A. Is this clear to all of your students? Is this clear to all students? To get the relation for torque, we simply added the torque for each constituent particles. Is it clear, students?
Yes.
Now what I'll do,
Yes,
I'll just try to substitute A1, A2, AN. Students, what is A1? R1 alpha. What is A2? R2 alpha. What is AN? Rn alpha. When I substitute A1, A2, what exactly torque will get it? We'll get it torque is equal to what? Suppose if I take A1 as R1 alpha, students, so what's the relation I'll get it? अगर मैं यहाँ पे r1 अल्फा डालता हूँ स्टूडेंट्स, so my answer will be m1 r1 square अल्फा. सेकेंड केस के लिए m2 r2 square अल्फा. थर्ड केस के लिए m3 r3 square alpha, so on for mn rn square alpha. If I want to go for net torque, students, what exactly I'll go for? Addition of all of them, where what exactly I'll remove? I'll remove alpha common, students. बाकी सारे को अगर एक टर्म्स में लूंगा तो कहना से ये क्या हो जाएगा? Algebraic sum of mi ri square, I equal to the first particle, I equal to n particle multiplied by alpha, students. ये देखो, if I go for a students bracket में अंदर तो m1 r1 square होगा plus m2 r2 square होगा plus m3 r3 square होगा plus m4 r4 square होगा. It can go on till mn rn square. I'm simply adding them and alpha is constant. That I've kept it aside. So what exactly I'll get within the bracket? It's an algebraic sum of mi ri square. And students, this is a formula for what? That's a formula for moment of inertia. Therefore, torque simply we can consider in terms of what? I into alpha. Is this clear to all the students?
Yes, sir.
Yes, sir.
So ये तुम्हारा torque के relation था, students. Now suppose if one asks you with respect to kinetic energy, can I get an answer for kinetic energy? Students, simply exactly same identically you have to go for it. Diagram वैसे ही होगा students, mass होगा, velocity होगा. लेकिन when I go for kinetic energy, students, which is the angular term over here, omega. So what do you do, students, instead of alpha keeping constant, you say that the entire system is set to move with constant angular velocity. So to get the relation for rotational kinetic energy, students, see to it that the entire system is set to rotate with constant angular velocity. Whereas when I went for moment of force, students, the entire system is set to move with constant angular acceleration. Hope this is clear to all the students.
Yes, sir.
Yes, sir.
Okay. Now listen carefully, students. I'll keep the diagram as it is, students. Simply we try to change the solution part of it, students. Now listen carefully, students. When you're speaking about with respect to kinetic energy, how do you go about, students? We go for a relation. Students, जब torque के बारे में था, so we took the support of torque is equal to what? R cross F. We use this mathematical relation. To get the formula for kinetic energy, students will go for translational first. We are going to use this relation. Students, let us find out the kinetic energy of the first particle as half m1 v1 square. Now, if I ask you students, अगर ये है tangential velocity, कोई भी body rotate होता है, students, listen carefully. तो उसके जो constituent particles होंगे, students, the constituent particles which are there, all the constituent particles which can be at different distances, students, all of them are performing what? Circular motion. ये होगा तुम्हारा tangential velocity. Omega is along where? Omega is along the perpendicular axis, students. ये हुआ तुम्हारा position vector for this particle. ये होगा position vector for this particle. Now, when I speak about translation kinetic energy, what's the translation kinetic energy of each particle? Half m1 v1 square. But now, if I give you a relation for linear velocity, position vector, and angular velocity, then students, we have a relation B is equal to R into omega. And this is, a student should know it when you learn it in motion in a plane. Students, it's a part of circular motion. Any body, students, any object, any body, any particle revolving in a given plane, its linear velocity is always represent as a product of position vector into angular velocity. V is equal to R omega. So we can substitute over here V as R omega. Now, जैसे मैंने omega को substitute करूंगा, students, जैसे मैं V को R omega रखूंगा, omega क्या है? Angular velocity है. When I substitute V as R omega, will I call this as translational kinetic energy, or now I will call this as rotational? Students, this becomes my rotational kinetic energy. Why? Because we are trying to change the linear motion to angular, we consider. So now, if I write down what is the kinetic energy of the first particle, it's half m1. Instead of v1 square, what exactly write down? So it's r1 omega the whole square. So it's half m1 r1 square omega square, we consider. That's the kinetic energy of the first particle, students. Is this clear to all the students?
Yes, sir.
Yes, sir.
Again, I repeat, students, we are trying to derive the formula for rotational kinetic energy. Half I omega square, measure in joules. लेकिन to get the relation मैंने किसका use किया? Translation kinetic energy का formula लिया. Half mv square. V क्या है? Tangential velocity. Can I get a relation between tangential velocity, position vector, and angular velocity? This is a relation. I have substituted V as R omega. I got the kinetic energy of the first, which is this kinetic energy. This is rotational. Now, if in case if I happen to go for kinetic energy for the second particle, I'll consider half m2 r2 square omega square. Like that, I can go for kinetic energy of the nth particle. So it's half mn rn square omega square. So students, what exactly the net kinetic energy of the system? The net kinetic energy of the system would be summation of all of them. Add all of them. जैसे मैं add करूंगा तो यहाँ पे क्या होगा students? Half common आएगा. Bracket में क्या होगा? So this will be m1 square. Sorry, m1 r1 square, m2 r2 square, m3 r3 square plus mn rn square omega square will be outside. Students, what is this? This is a relation for which mathematical expression? So ये तो आपका सिर्फ summation है. किसका है? ये summation, it's a product of mass of each particle and square of the distance of that particle from the axis of rotation. यानी students ये क्या है? This is the moment of inertia, students. ये है moment of inertia. So can I say it's half into moment of inertia and omega square. So what's the formula for kinetic energy? Half I omega square. Is this clear to all of you?
Yes, sir.
Okay. So we have got the two relations, torque is equal to I into alpha, kinetic energy is equal to half into I into omega square. Now suppose students, if I ask you, can you get the relation for angular momentum by yourself? The last one. See the approach of for these two. Almost identically, you have to go for this one. यहाँ पे I used torque R cross F to get the answer. यहाँ पे I used translational kinetic energy to get my answer. I'll give you a hint. To get the angular momentum, students, I'm taking the help of angular momentum is R cross P. I'll take the formula R cross P and get my answer. Can anybody solve for L equal to I omega? Students, anyone? Angular momentum I into omega. The diagram almost remains same, students. Har ek ko main mass, I'm considering several masses. Tangential velocity I've given to you, position vector I've given to you, and the entire system is moving with constant angular velocity. Angular momentum is R cross P. Yes, anyone? Students, why are you thinking so much, students? How to go about with the students? Your angular momentum is r cross p, students. So just try to find out angular momentum we consider for each particle. For the first particle, students, ये क्या होगा? R1. What is linear momentum? Everybody should know linear momentum. So mass of the first body into the linear velocity of the first body. Hope this part is clear. Just now, before this, I told you the formula. What's the relation between V, R, and omega? V is equal to R omega. Friends, can I substitute V as R and omega? What
Yes,
exactly?
sir.
The first body आ गया. Angular momentum of the first body क्या होगा? Sir, ये R1 है, ये M1 है. V1 की जगह पे what I'm going to write down, students, now? It will be R1 into omega and not omega 1. Why? Because omega is constant. Students, when you want to derive the formula for torque is equal to alpha, please, I made it very clear. Keep alpha constant. When I said for kinetic energy and angular momentum, keep omega constant. So when you start off with your mathematical relation, students, the statement we have to say, consider a rigid body rotating about an axis passing through its center of mass and perpendicular to the plane. If I want to go for the derivation for the first one, it is rotating about that axis with constant angular acceleration. If I want to go for the mathematical relation for these two, you have to say it's rotating about the same axis with constant angular velocity. Now, when I look into this, yes, I got the angular momentum for the first one. It's m1 r1 square omega. So सारों में एक common pattern create हो रहा है. सारों में तुम्हें m1 r1 square मिलेगा, m2 r2 square मिलेगा, m3 सबको एक साइड रख दो, समीशन में आ जाएगा. Constant terms को बाहर दे दो. जो constant terms आ गया, वो expression के अंदर बाहर आ जाएगा. So now this is angular momentum of the first one. Angular momentum of the second one is m2 r2 square omega. Angular momentum for the nth particle, mn rn square into omega, students. Now suppose if I happen to go for the net angular momentum of the system, so what exactly will consider? So addition of all of them. इनको अगर मैं add करता हूँ students, तो ये क्या हो जाएगा? So ये हो जाएगा algebraic sum of mi ri square, I equal to the first particle, I equal to the nth particle into omega. Students, is this the mathematical relation for moment of inertia? Of course, moment of inertia of a rigid rotating body is defined as the algebraic sum of product of mass of each particle and square of the distance of that constituent particles from the axis of rotation. That's why if the masses are slightly in discrete manner, we can go for this. Agar mass continuous manner hai, so I can go for integration of dm into r square also. ये भी मेरा एक mathematical relation है. ये कभी use करोगे, ये कभी use करोगे, दोनों का आंसर कैपिटल आई है स्टूडेंट्स. ये भी मोमेंट ऑफ इनर्शिया है, ये भी मोमेंट ऑफ इनर्शिया है. लेकिन यहाँ पे हम करेंगे यूज जब ये पार्टिकल्स डिस्क्रीट मैनर में है, यानी पार्टिकल्स आर स्लाइटली स्कैटर्ड. ये कभी यूज करोगे when the particles or the masses are distributed in continuous manner. जब भी continuous distribution of mass होगा ना स्टूडेंट्स, तो integration of dm into r square. और जब भी masses continuously distributed नहीं है, discrete manner में है, discrete manner यानी they have been separately we consider, then in that case I can go for this. But in both the cases, what is the answer for this? It's I into omega. Is this clear to all of you?
Yes, sir.
Students, the pattern which you need to follow for all these students, now listen carefully. Whenever they ask you to derive it, students, in short, you can write down your relations. So I'm going to erase this part. is whenever you go for expression for torque, okay, always select R cross F. Okay, it's a cross product. Torque is maximum, theta is 90. Then you go for F as mass into acceleration. This is tangential force, tangential acceleration. How's the flow of the derivation? Tangential acceleration, students, is given by the formula R into alpha, and over here is alpha constant. ये तो मैं बताना सकती. So now if I say torque is equal to what? mr square into alpha, that is I into alpha. That's the formula for torque. This is the first relation, students. यहाँ पे हम लोग ने alpha को constant लिखा है. See what is the formulas I'm using it. Tangential acceleration is R into alpha. ये एक formula. Alpha is constant. I'm putting this, and the next one I'm using is I as mr square. So with the help of these three things, we can simply get the derivation for torque. Now, when I go for kinetic energy, I'll first go for translational, that is half mv square. When you're going for this, students, we go for omega constant because we want to go for rotational dynamics. Do we have a relation for V? Yes, it's R into omega. Can I substitute back over here? Yes, it's half into m into what? R into omega the whole square. So what's my answer? Half into m into R square omega square. What is mr square? I. So what is K? Half I omega square. Students, when you are in your learning process, in short, you need to know this. इसके बाद में जो मैंने diagram वगैरह किया, students, that is the entire decoration of your answer sheet. You have to go for a well-mannered way of approach towards presenting your answer. तो उसको तुम थोड़ा सा एक formality में करते हो, एक diagram बनाते हो, फिर उसको diagram को थोड़ा सा express करते हो by few English statements. Consider so and so having so and so masses at so and so distances from the given axis of rotation. The angular term of this particular body remains constant. The linear terms associated are so and so. Now let us find out so and so, and then you go for it. So ये एक decoration होता है students answers का, and then finally you land up. लेकिन whenever you go for the learning process, when you're in the learning process, you should know the format के होता क्या, how to go about this. Last के लिए angular momentum के लिए what I need. So इसके लिए मैं R cross P की help लूंगा मैं. फिर ये भी क्रॉस प्रोडक्ट था, ये भी क्रॉस प्रोडक्ट था. शायद तुम लोग ने प्रॉब्लम्स भी किए होंगे in vectors. When you must have done calculus, you must have done a question onto this, or might be onto this also. You must have used your Kramers rule or the determinants ka rule in order to get the answer for angular momentum magnitude. So R cross P we can consider. Now when you look into it, what exactly P? I can go for linear momentum, mass into linear velocity. But what is linear velocity? R into omega. So can I say, when I go for it, L is equal to R. Instead of P, I'll write an M into V. Now see, in the second step, what I'm putting it, V को मैं क्या substitute करूँगा? R omega. Now am I getting the answer as mr square into omega? So students, everywhere I need to get mr square. Everywhere I need to get mr square. Everywhere I need to get, because I need I. So that is equal to what? I into omega. क्या ये clear हुआ, students?
Yes, sir.
Yes, sir.
Now can I erase this entirely?
Yes, sir.
Okay. Yeah, students, once when you got the relation for this angular momentum, students, okay, one can simply go for a concept related to it. See, students, when you go for mechanics chapter, okay, you might come across further ahead a concept of law of conservation of linear momentum. Hope you must have got that. Those who have done laws of motion, Newton's law of motion, you all must have come across over there law of conservation of linear momentum. The total momentum in an absence of external force, students. In an absence of external force, students, the total momentum of the body before collision is exactly equal to the total momentum of the body after collision, students. Exactly identically, we can go for your law of conservation of angular momentum, students. Okay, it's simply analog. It's a kind of analog. वहाँ पे linear momentum, यहाँ पे angular momentum. So now we students go for conservation of angular momentum. The next concept I'll put forward is conservation of angular momentum. Since the variable used for angular momentum is L. Since अगर तुम law of conservation of linear momentum के बारे में पढ़ोगे तो वहां पे तुमने पढ़ा होगा in absence of any external force, and there is no force acting on the body, the total momentum before collision is equal to total momentum after collision. Exactly the same statement we have. यहाँ पे in absence of external force, students, यहाँ पे in absence of external torque. There is no torque acting on the system, students. The total angular momentum before is exactly equal to the total angular momentum of the system after collision. It's the same manner, but we need to go for in absence of external torque. Let us go for a short mathematical derivation to prove that the angular momentum of a body is conserved. Mathematically, let us derive those equations, students. Now, students, when you speak about for angular momentum, students, when I speak about in terms of it, can I go for your concept of your angular momentum, students? Your angular momentum is equal to what? L. The answer is, students, it's L is equal to what? You see, sir, it's R cross P. That's in vector form we consider. Now, suppose if I say, students, differentiate both the sides with respect to time. Listen carefully. ये किसका relation है? Sir, ये angular momentum है. किसके लिए है? For a body rotating about its own axis. And I made it very clear in the last lecture, students. कोई भी body अगर rotate करता है about its own axis, linear terms will be always along y-axis. Position vector will be always along x-axis. And the angular term will be along z-axis. अगर motion anti-clockwise है, अगर motion anti-clockwise है, the angular momentum will be along positive z-axis, that is plus k cap. And this already you'll have learned it in vectors, right-hand screw rule. Students, in the last lecture also made it very clear where can one use cross product. Yeah, vector products of two vectors we consider. The cross product in physics. In physics, cross product is used throughout in only those chapters where we speak about circular motion, or we speak about rotational motion, or we speak about any particle moving along the circumference of the circle, or motion of a particle along an arc, along an simply arc with constant radius. जहां पे motion along the arc हुआ with constant radius हुआ तो वहां पे भी we can use cross products. So do take care, students. Whenever you're going for cross products in physics, always go for circular path we consider, or rotational motion we consider, students. Now let us go for this. Your angular momentum, students, is equal to r cross p. I told you to differentiate. So dl by dt. यहाँ पे जब हम differentiate करोगे तो what exactly? सर ये तो position vector है. Position vector तो हमेशा constant होगा, students. Are you getting it? So now if I say it will be r into what? dp by dt we consider. Agreed, students? What exactly rate of change of momentum? So this is what dp by dt. What is rate of change of momentum? What I call this as? Force. So dl by dt I can put in terms of r cross f. What is r cross f, students? Ta. क्या ये clear हुआ, students? ये external torque हुआ. Now what is my statement? What is my statement? What does conservation of angular momentum says? In absence of external torque, बाहर से कोई टॉर्क नहीं होना चाहिए, स्टूडेंट्स. तो अगर मैं टॉर्क को 0 ले लूं तो मेरा dl by dt will be equal to 0. यानी what exactly the angular momentum of the system remains constant. If dl by dt is equal to 0, students, what about angular momentum? Angular momentum of the system all the time remains constant. And this is what a simple mathematical relation for law of conservation of angular momentum, students. क्या ये क्लियर हुआ, स्टूडेंट्स?
Yes, sir.
Differentiating both the sides with respect to time. Position vector for a particle rotating about its own axis all the time remains constant. For that particular particle, position vector never changes. ध्यान से सुनना, अगर ये एक्सिस है और यहाँ पे पार्टिकल है, ये पोजीशन वेक्टर है, ये इसका टेंजेंशियल टर्म्स है, जैसे जैसे पार्टिकल रोटेट होगा सीधा पोजीशन वेक्टर, द पोजीशन वेक्टर डज नॉट चेंज, तो ये कांस्टेंट ही होगा, कांस्टेंट टर्म्स कैन नॉट बी डिफरेंशिएटेड, उसको मैंने बाहर निकाल दिया, रेट ऑफ चेंज ऑफ मोमेंटम को फोर्स डाल दिया, व्हाट इज r क्रॉस ऑफ टाउ। एंड ये कांसेप्ट क्या है स्टूडेंट्स, ये कांसेप्ट ये है कि अगर सपोज मैंने ये बोला करके कि the force acting on the particle is equal to 0 in that case. What about the momentum in that case? All the time remains constant. The angular momentum remains constant. ये concept लेते हुए what exactly we try to prove? We can simply say, students, the angular momentum. Students, the total angular momentum of the system before collision is exactly equal to the total angular momentum of the system after collision. And what is the formula for angular momentum, students? I into omega. Let us say the angular momentum in the first case. This is case 1. This is case 2. Before and after. So can I say angular momentum is I1 omega 1 will be equal to I2 omega 2. Students, from where did I get this? L is equal to I omega कहाँ से मिला सर? इसके पहले वाले फ्रेम में, इसके पहले वाला जो आपने डेरिवेशन किए थे, 3 डेरिवेशन किए थे. Students, 3 derivations I made it to happen in front of you. Torque we consider is equal to what? I into alpha. Kinetic energy rotational half I omega square. और तीसरा वाला ये वाला था. तो स्टूडेंट्स, ये अगर मैं फॉर्मूला यूज कर रहा हूँ तो मैं पीछे से यूज कर रहा हूँ, यानी जो चीज मैं डिराइव कर चुका हूँ उसी को मैं आगे ले रहा हूँ. तो अगर मैंने बोला एंगुलर मोमेंटम ऑफ द सिस्टम रिमेन्स कांस्टेंट, तो दिस इज द मोमेंट ऑफ इनर्शिया ऑफ द सिस्टम इन द फर्स्ट केस, एंगुलर वेलोसिटी ऑफ द सिस्टम इन द फर्स्ट केस, मोमेंट ऑफ इनर्शिया इन द सेकंड केस, एंगुलर वेलोसिटी, दिस इज बिफोर एंड दिस इज आफ्टर, दैट रिमेन्स कांस्टेंट. अगर इसी को तो मैचअप करते हो ना स्टूडेंट्स, इसी को मैचअप करते हो विद लीनियर मोमेंटम के हिसाब से, तो क्या पढ़ा था? What exactly law of conservation of linear momentum में तुमने पढ़ा? Students, you must have learned it. m1u1 plus m2u2 is equal to m1v1 plus m2v2. Can we put in vectors also? Why not? I can put this also in vectors. Students, ये initial momentum of the two bodies before collision is equal to the final momentum of the body after collision. And students, this part is already done, law of conservation of linear momentum, to all the students in your school level in class 9th. Law of conservation. सब लोगों ने पढ़ा होगा. वापस Newton's laws of motion में you all must have done it in class 11th. Because whenever you learn about momentum, it directly goes with law of conservation of linear momentum also, students. Now suppose if I give a simple mathematical way of approach, तो ध्यान से सुनो स्टूडेंट्स, इसके रिलेटेड कैसे टाइप के प्रॉब्लम्स होंगे? स्टूडेंट्स, ये एक व्हील दिया हुआ है, ध्यान से सुनो स्टूडेंट्स, ये एक व्हील दिया हुआ है और ये हॉरिजॉन्टल सरफेस है, ये दूसरा व्हील दिया है स्टूडेंट्स. अगर मैंने बोला व्हील है तो ऑफ कोर्स दे आर मेड टू rotate about its x axis. Okay, let us say this particular wheel has a moment of inertia of I1. It is rotating with angular velocity omega 1. Agreed? This is I2 has an angular velocity omega 2. The answer, students, both these wheels are moving in the same direction. Am I getting it? Such that the angular velocity of the first body is greater than the second one. After collision, what happens? This body moves with a new angular velocity we consider. यानी इसका angular ये body का angular velocity will now change in this case. Are you getting it? So now suppose if I say this body is set to move in the forward direction, even this body also moves in the forward direction. So इसका angular velocity decrease हो सकता है, इसका angular velocity increase. So let us say this is omega 2 dash. What is this for the first one? So इसका angular velocity now will be omega 1 dash. This is after collision. The moment of inertia of the body, students, moment of inertia change नहीं होता है. इसका moment of inertia I1 ही रहेगा, इसका moment of I2. लेकिन ये after collision, ये before collision. Students, was there any external force? No. Both of them were set to rotate and they were moving along a straight path. Both the bodies were set to rotate and means actually it's a rolling motion. Students, इसको हम बोलते हैं rolling motion. क्योंकि rotational के साथ में एक translational motion भी हो रहा है. So that's called as rolling motion. but such that iska velocity, angular velocity is greater than omega 2, तो क्या होगा? So there will be some collision. Let us say that collide at a certain instant of time t. After collision का diagram ये है. After collision हुआ क्या? Sir, इसकी velocity शायद decrease होगी, इसकी velocity शायद increase होगी. So now, can I use law of conservation of angular momentum over here? Yes. What is the total angular momentum before collision? We'll say, sir, I1 omega 1 plus I2 omega 2. What is the total angular momentum after collision? We'll say, sir, I1 omega 1 dash plus I2 omega 2 dash. Suppose अगर मैंने इसकी angular velocity दे दी, तो can I get the answer of this one? क्या ये mathematical relation clear हुआ? Exactly.
Yes,
Your linear motion, जैसे कि m1 u1, m2 u2, m1 v1, m2 v2. Is this clear, students?
Yes, sir.
Yes, sir.
It's only students, when you learn more, it is lots of way of approach are there for this collisions. कोई hit होके वापस recoil होगा, कोई hit होने के बाद में एक rest पे आ जाएगा, दूसरा motion में आ सकता है, या ये भी possible होता है कि after collision दोनों साथ में चले गए. So दोनों अगर साथ में चले गए तो लेफ्ट हैंड साइड का तो वही आएगा. So दोनों अगर साथ में चले गए तो लेफ्ट हैंड साइड का रिलेशन ये आएगा, लेकिन राइट हैंड साइड का क्या होगा? So दोनों अगर साथ में चले गए तो दोनों both the bodies are in contact. What is the total moment of inertia of the system? Addition of the two. Now the system moves with a new angular velocity omega. Yani students, your formula will be I1 omega 1 for the first body, I2 omega 2 for the second body. But now, if both the bodies comes in contact with each other, now they move with an angular velocity omega, one can easily find out this omega also. Law of conservation of angular momentum is obeyed. Is this clear, students?
Yes, sir.
All of you all. Please, students, I'm not teaching hardly one or two
Yes,
or three.
sir.
There are a few of them who are there over here. I don't know about it, how exactly you're taking your studies in this case. Harshal. Doesn't matter, Harshal. But see to that you should get what exactly has been done when you're entering into a particular lecture, students. Okay, I hate students who entered forcefully. If you're entering for some reason, then at the end of it, you should feel that, you know, I'm able to come in, I'm able to get it, I'm able to catch it. So please see to it that if any kind of things which you are not able to connect it right now, unmute yourself and ask, or post yourself and ask. Can I erase this now?
Yes, sir.
Okay.
Just a minute, sir.
This must be Pu. Yes, it must be Pu. You, how come Mona Lisa is showing a V?
Done, sir. Sorry, sir.
You, तू भी है ना, बहुत स्मार्ट है. थोड़ा सा मैं बैठने का ट्राई करता हूँ, उसी में तो भूल जाती कि सर डन. मतलब
Sir, I wasn't doing.
मुझे लगा करके तो शायद 1 मिनट लगेगा करके तो थोड़ा सा मैं बैठ जाऊँ और रेस्ट ले लूं, लेकिन तू वापस जैसे मैं तू जानबूझ के ये कर दे, जानबूझ के तो पता चल कि अभी ये बैठेगा ना तो वापस उसको खड़ा कर देता है ना. यू वेरी स्मार्ट. If you, I was just joking, okay? Doesn't matter. Okay, students. Now we go for two important mathematical relations, students. Okay. So 2 more relations and 1 is rolling motion. That will be the end of the chapter, students. Okay. Now listen carefully, students. The 2 relations, what you are going to learn as students, the 2 important theorems. One of them is called as your perpendicular axis theorem, students. And the other one is parallel axis theorem. So these two theorems are important enough because at times when you're moving further as students, when you're trying to move further with your approach towards either NEET or JEE Mains or Advanced, students questions onto this can be asked, problems can be asked onto this. So I'm going to give you the mathematical relation for it, students. Now, what is this perpendicular axis theorem and why do we need to learn this? Why do we need to learn this? What's the reason behind it? And why do we need to go for this? Now, to understand this perpendicular axis theorem, please pay attention. Suppose अगर तुम्हें मैंने एक rigid lamina दी, please pay attention students, okay? Rigid lamina दिया, okay? तो now अगर मैंने ये rigid lamina दिया, ये पूरा matter है students, okay? पूरा matter है. And now if I say students rotate this lamina about a given axis, so a person A will say, sir, can I take the axis? Let me take this as A, B, C, and D. So person A will say, sir, can I take an axis passing along AB and this becomes my axis of rotation? क्यों नहीं? यानी पूरा system is rotating about AB as the axis of rotation. यानी इसके हिसाब से I'll get a moment of inertia. That's a moment of inertia in the first case. Now, if I give the same body to person B, what exactly he will do? He will try to take AD as the axis of rotation, and he can make the entire system to rotate in that. The moment of inertia will be I2. Students, are you all getting it?
Yes, sir.
एक ही लैमिना, a given lamina, शायद मैंने अभी स्क्वायर फॉर्म में दे दिया स्टूडेंट्स, चलो ये रेक्टेंगुलर फॉर्म में, ये सोचो कि ये रेक्टेंगुलर फॉर्म है, चलो I'll shift this positions, okay, and try to go for slightly longer. Are you getting it? So this is A, B, C, and D. Now see students, I've changed the axis. First person will try to make the entire lamina, rectangular lamina ABCD to rotate about AB. The other one will go about AD. Now, third person might go for it. Is, sir, can I take the entire system and make it to rotate about point A? अरे हाँ यार, ये भी तो हो सकता है ना? देखो पूरा frame ऐसे rotate हो रहा है. This entire will rotate. This is now
हाँ,
यानी
sir.
होगा. I getting it? It's going to come in this way. So it can be rotated. And what exactly? There are three. And I've gone for three such moment of inertias. And why am I going for these three? Because in these three students, we are getting a pattern. What kind of a pattern I'm getting it? Sir, आप I1 देखो, I2 देखो, I3 देखो, तीनों अगर एक्सिस को देखोगे ना, तो सर ऐसा लगता है कि I3 और I2 के बीच में 90 डिग्रीज का है. Why not? If you look into I2 and I1 के बीच में भी 90 डिग्रीज है. Students, ये I3 और I1 के बीच में भी 90 डिग्रीज है. यानी are these three axes mutually perpendicular to each other? Absolutely
Yes,
correct.
sir.
इसको मैं ले सकता हूँ along x axis, इसको मैं ले सकता हूँ along y axis, इसको मैं ले सकता हूँ z axis. Then students, can I get a relation between the moment of inertia of all these three axes? Yes, that is called perpendicular axis theorem. Moment of inertia about an axis perpendicular to the plane lamina is equal to sum of, listen carefully to the statement, is equal to the sum of the two mutually perpendicular axes passing through a point where the perpendicular axis cuts the lamina. That means I have one axis along x, one axis is along y, and the third axis is along z. So iz is equal to ix plus iy. Now the statement, moment of inertia about a given axis, is equal to the moment of inertia of the two mutually perpendicular axes along the plane. Am I getting it? Where the perpendicular axis cuts the lamina. So moment of inertia about a given axis perpendicular plane is equal to the sum of the moment of inertia of two mutually perpendicular axes where the given axis cuts the lambda. यानी IZ कट करता है. अभी देखो ना, मैंने कॉर्नर पे लिया स्टूडेंट्स, मैंने ये कॉर्नर पे लिया, इसी बॉडी को तुम ऐसे भी तो रोटेट कर सकते हो ना स्टूडेंट्स। चलो मैंने ये पूरा एक्सिस को शिफ्ट कर दिया, अगर मैं शिफ्ट कर दूं तो स्टूडेंट्स कहना से ये मेरा एक एक्सिस होगा, ये मेरा दूसरा एक्सिस हुआ और ये मेरा तीसरा एक्सिस हुआ, क्या ये तीनों भी परपेंडिकुलर है? यस, व्हाई नॉट? यानी स्टूडेंट्स कोई भी अगर मैं रिजिड लैमिना लूं, आई कैन मेक द बॉडी टू रोटेट अलोंग 3 डिफरेंट एक्सिस, तो उनका एक रिलेशन जो आता है दैट इज कॉल्ड परपेंडिकुलर एक्सिस। क्या ये क्लियर हुआ स्टूडेंट्स?
Sir, can you repeat the statement?
Moment of inertia about an axis perpendicular to the plane lamina, students. Okay, perpendicular to the plane lamina, students, is equal to the sum of the moment of inertia of two mutually perpendicular axes where the given axis cuts the lamina. So all these three will try to meet at one point. Students, is it clear?
Yes, sir.
Yes, sir.
Okay. So the formula is Iz, moment of inertia about a given axis perpendicular to the plane lamina, is equal to sum of the moment of inertia of two axes mutually perpendicular to each other, and these two are along the lamina, but where exactly they pass through? They pass through a point. They pass through a point where the perpendicular axis cuts the lamina. See the statement. I repeat, moment of inertia about a given axis perpendicular to a plane lamina is equal to sum of moment of inertia of two mutually perpendicular axes passing through the point where the perpendicular axis cuts the lamina. So now when you go for any kind of lamina structure, students, in this manner, I can go for a simple diagram I can consider. Let me take this as Ix, this will be Iy, this will be Iz. Hope this part is clear to all of you. This is perpendicular axis. What about parallel axis theorem, students? Parallel axis theorem क्यों पढ़ना पड़ रहा है? Reason क्या है? हमें ये क्यों पढ़ना पड़ रहा है? क्योंकि स्टूडेंट्स जब भी हम कोई भी बॉडी को रोटेट करते हैं ना स्टूडेंट्स, ध्यान से सुनना। सपोज अगर मैं स्क्वायर लैमिना लूं या मैं रेक्टेंगुलर लैमिना लूं या मैं डिस्क लूं, तो स्टूडेंट्स हम क्या करते हैं? Most of the times we always try to make the body to rotate about the center of mass. Most of the time students we always, क्यों? क्योंकि मुझे body equilibrium में चाहिए. Students, I want rotational equilibrium. Students, when the body is rotating, the answer is students, when the body is rotating, I don't want the body to move to here and there. If I try to make a body to rotate, students, if I try to make a body to rotate about the center of mass, the motion can be uniform. It can be considered क्योंकि distribution of mass equal हो जाता है throughout. और हमने CM को पॉइंट लिया है और एक्सिस को वहां से पास किया है. यानी जब भी हम डेरिवेशंस लेते हैं, हम कुछ भी प्रॉब्लम्स या वी ट्राई टू अंडरस्टैंड अ कांसेप्ट, वी ट्राई टू गो फॉर द एक्सिस पासिंग थ्रू सेंटर ऑफ मास. लेकिन नाउ अ स्टूडेंट कैन से सर, क्या जरूरी है जब भी आप मोशन के बारे में बात करते हो तो क्या जरूरी है कि आपको सेंटर ऑफ मास से मूव करना है? मुझे नहीं करना है, मुझे नहीं करना सेंटर ऑफ मास. अगर सपोज मेरा एक्सिस चेंज हो जाता है, मुझे यहाँ पे लेना है, मेरी मर्जी, मुझे यहाँ पे लेना है, तो आप कैसे निकालोगे आंसर? मेरी मर्जी, मैं चाहे ये करूं, मैं चाहे वो करूं, मेरी मर्जी. आई वांट टू टेक इट एट पॉइंट 2. अभी इसका आंसर कैसे निकालोगे आप? आई गेट इट. अगर मैं इरेगुलर लामिना दो तो देखो ध्यान से देखना स्टूडेंट्स, यहाँ पे अगर तुम देखोगे तो यहाँ पे ज्यादा मास डिस्ट्रीब्यूशन, तो मेरा सेंटर ऑफ मास ही होगा. एक्चुअल मेरा एक्सिस इधर से होगा तो मेरा बॉडी अच्छी तरह से रोटेट होगा, इक्विलिब्रियम में होगा. ये पूरा लामिना ऐसे विल नॉट मूव टू एंड फ्रो, इट विल रोटेट परफेक्टली. But now suppose if I take a point somewhere else other than the center of mass, then how do I get it? Then students, for that we need to go for parallel axis theorem. Now for diagram for parallel axis theorem, what exactly simply you consider? Now let us say I'm taking an irregular rigid lamina, thickness negligible. Let us say this is the center of mass. So this is IC. The body should have been rotating over here, but I don't want to go for this. Sir, I want the entire system to be rotated about this. यानी जो मेरा मेन एक्सिस है उसको मैंने स्ट्रेट लाइन से ड्रॉ किया है, जो मेरा पहला वाला एक्सिस था इमेजिनरी था वो सेंटर ऑफ मास से पास हो रहा है। तो आई वांट टू फाइंड आउट मोमेंट ऑफ इनर्शिया अबाउट का ABOUT, उसका O मैंने यहाँ पे दिया है। So now if I want to go for moment of inertia about a given axis we consider, then how do you go about for this? इसका कैसे निकालोगे? So let us say that the distance between both of them, students, let me take this as h. Are these two axes, students, are these two axes cutting the lamina? Are these two axes cutting the lamina? हाँ sir, एक ऐसे सेंटर से पास हो रहा है. See, one is over here and one is over here. Since one is passing to the center of mass and one is passing at a point about. Are they cutting the lamina? Yes. But are these two axes parallel to each other? Yes, sir. Are they at a distance h from each other? Yes. That is what's called as parallel axis theorem. Now, suppose if somebody asks you the mathematical relation, what exactly the moment of inertia? Sir, moment of inertia. Listen carefully to the statement also, students. Moment of inertia about a given axis. Moment of inertia about a given axis perpendicular to the plane lamina is equal to the sum of moment of inertia about an axis always passing through its center of mass, and the product of mass of the entire body, and square of the distance between the two parallel axes. This is the formula for parallel axis theorem. I repeat, moment of inertia about an axis perpendicular to the plane lamina. Moment of inertia about an axis perpendicular to the plane lamina is defined as, or is equal to the sum of moment of inertia about an axis passing through its center of mass and the product of mass of the entire lamina and the square of the distance between the two parallel axes. And what's the distance between the two parallel axes are given by variable h. Are these two mathematical relations clear, students?
Yes, sir.
Yes,
Now
sir.
if I give you simple relations, students, इसका एक simple mathematical हम formula लेते हैं, students. Suppose अगर ध्यान से देखना students, अगर मैंने ring दिया, everybody now please pay attention, okay? अगर मैंने ring दिया students, मैंने पूछा है for this uniform ring, students, can you tell me what will be the moment of inertia for the ring to be rotated along the diameter? क्या इसका तुम आंसर निकाल सकते हो? यानी ये फॉर्मूला है, ये प्रॉब्लम दे दिया मैंने, मुझे चाहिए मोमेंट ऑफ इनर्शिया along the diameter. How do you think about it? How do you think? सर ये जो रिंग है, ये रिंग है, I can put in this manner, ये रिंग है. सर आपने पूछा along the diameter. अगर मैं डायमीटर को लेता हूं तो अरे सर ये डायग्राम को अगर मैं इससे मैच करता हूं तो सर ये वाला एक्सिस मुझे चाहिए, तो इसको मैं ले लेता हूं Ix, जो मेरा एक डायमीटर तो बन ही सकता है. हाँ सर, ये देखो ना सेंटर ऑफ मास से पास हो रहा है, तो आपने मुझे Ix पूछा है, तो सर Ix के साथ में Iy भी तो है. तो अगर सपोज मैंने यहाँ से एक एक्सिस ले लिया तो क्या ये क्या हुआ सर, ये हुआ Iy, लेकिन क्या ये भी तो डायमीटर है ना? अरे हाँ सर, ये भी डायमीटर है स्टूडेंट्स, क्योंकि ये रिंग है. For a ring, if I try to go for an axis passing through the center of the ring in that case, then that becomes my moment of inertia along the diameter. Identically, I've taken one more. How are these two mutually perpendicular? What about the third axis, students? The third axis is z-axis. How exactly z-axis should be? So it should be always perpendicular to the plane line. And that is what? Iz. Is this z-axis passing through the center of mass of the ring? Yes. And students, do you know the formula for this? Already, sir, you have given us. In the last lecture, आपने बोल दिया था moment of inertia about an axis passing through the center of mass of a ring and perpendicular plane is given by the formula mr square. Students, क्या ये formula clear है first of all?
Yes, sir.
Moment of inertia about an axis passing through center of mass and perpendicular to the plane is given by the formula mr square. Oh, यानी सर मुझे Iz पता है, मेरा फॉर्मूला है Iz is equal to Ix plus Iy. अच्छा सर, Iz यानी सेंटर ऑफ मास यानी ये mr स्क्वायर मुझे पता है. आपने पूछा along diameter. Ix क्या है सर? Ix भी तो diameter है. Iy सर वो भी तो diameter है. ओ सर आंसर मिल गया. यानी mr स्क्वायर क्या होगा सर? mr स्क्वायर will be equal to twice moment of inertia along the diameter. So what's the moment of inertia along the diameter? What's the moment of inertia along the diameter? Half the moment of inertia passing through the center of mass and perpendicular. क्या ये clear हुआ students?
Yes, sir.
Yes,
How
sir.
to put into application? How to put into application? और ये ध्यान रखना स्टूडेंट, जब भी तुम इसके क्वेश्चंस करोगे ना, मोस्ट ऑफ द टाइम्स द क्वेश्चंस विल बी ऑन टू सर्कुलर ऑब्जेक्ट्स. जैसे रिंग हुआ, डिस्क हुआ, आई कैन कंसीडर फॉर दैट. सिलेंडर हुआ, आई कैन गो फॉर दैट. यानी these are all for circular objects. You can easily use your formulas for perpendicular axis theorem. लेकिन हमेशा ये ध्यान में रखना कि these two axes should be mutually perpendicular to each other, and they should pass through center of mass. They should pass through center of mass, but at the same time, I can take it other than center of mass also. Why not? I can take it other than that. जरूरी नहीं कि center of mass, it can go somewhere else also. Now, for example, if I say, students, if in case if I happen to give you a rectangular lamina or a square lamina, students, I want to find a moment of inertia about this. So I can go for this part. अगर मुझे ये पता है और अगर मुझे ये पता है, तो दोनों को ऐड करके can I get I z? Why not? I can get I z easily. या सपोज मैंने ये यहाँ पे ले लिया, तो I can get for that also. Likewise, अगर मैंने ये रिंग लिया, so देखो यही रिंग मैंने लिया है, ध्यान से सुनो स्टूडेंट्स, ये मैंने सेंटर से किया. Suppose if I now ask you, I'm taking it in this way. Agreed? Can I say this is one tangent? This is another tangent. Is this passing through the diameter? Why not? Is this tangent? Yes. Can I take this as Ix? Yes. I can take this as Iy. Can I find out Iz? Why not? Lekin, provided you should know the moment of inertia for these two. Unless and until you don't know the proper relation, you cannot crack it. So you need to know the moment of inertia passing through the diameter, passing in this manner, and perpendicular. You can get your answer. So we as students, when you go for it, Iz is equal to Ix plus Iy. Can I erase this example, students, for perpendicular axis? Students, can I erase it?
Sir.
Yes.
So this Iz equals to Ix plus Iy is only valid when these are passing through the center, right?
Yes.
And
Other than centers, you need to know the relations of Ix and Iz and Ix and Iy.
and according to that, then we can substitute like from this Iz equals to Ix plus Iy, right?
Yes, absolutely correct. और इसका आंसर कैसे निकलता है मालूम है? इसका आंसर तुम निकाल सकते हो by using parallel axis also. So it's a combination of both. Now see, अगर suppose if I happen to go for this, I can easily, अगर मैं कोई एक axis यहाँ पे ले लेता हूँ, तो ये parallel हो गया. I can get the answer. अगर मुझे इसका आंसर है तो मुझे इसका आंसर मिल गया. सेम इसका भी होगा. अगर मैं स्क्वायर लामिना लिया तो वही आंसर यहाँ पे होगा. Likewise, अगर ये है, suppose if you look over here, ये देखो ये वाला tangent जा रहा है. If I know this part of it, can I get this? अरे हाँ सर, ये दोनों parallel है.
Oh,
I
yeah.
can parallel axis. So you have to use a combination of both to get the answers accordingly. Can I now erase, students?
Yes, sir.
Okay. Now, students, parallel axis theorem के लिए listen carefully. Your formula is moment of inertia, students, about any axis is equal to moment of inertia passing through the center of mass plus mass into square of the distance. Students, how do you go about this? Let's take a simple example, students, for this part of it. Suppose if I happen to go for a thin uniform wire. Let us go for thin uniform wire of length L, students. This is center of mass. Since my question is, I want to find out moment of inertia about an axis. This is point A, this is point O, and this is point B. I want to find out moment of inertia. I take this as C. I want to find out moment of inertia about point O. ये question पूछा. स्टूडेंट्स ये पूरे रॉड को मैं रोटेट करता हूं अबाउट पॉइंट, यानी आई वांट टू गेट आई नॉट. हाउ डू आई गेट आई नॉट? मोमेंट ऑफ इनर्शिया अबाउट अ गिवन एक्सिस को निकालने को व्हाट्स द रिलेशन? सो मोमेंट ऑफ इनर्शिया अबाउट अ गिवन एक्सिस इज इक्वल टू सम. There should be moment of inertia. I should know for an axis passing through the center of mass. Okay, Yani sir, you need the help of this part of it. Yes. Students, do I know the moment of inertia for a rigid uniform beam passing through the center of mass? Yes. I'd give you the formula ml square by 12. Agreed? Length L है. Students, ये क्या होगा? Sir, ये half होगा. Can I say these are now two parallel axes? हाँ sir, ये दोनों parallel axes हैं. Are they perpendicular to the rod? Yes, they are perpendicular rod. What exactly the distance between two parallel axes? That is h. Sir, this will be L by 2. So moment of inertia about a given axis perpendicular to the rod at one end is equal to moment of inertia passing through the center of mass plus mass of the entire rod into square of the distance between the two parallel axes. Now can I get the answer? I0 is equal to IC, and IC is ml square by 12 plus m. What is h? L by 2 the whole square. This one's, can I get it? Ml square by 12 plus ml square by 4. So what's the answer for moment of inertia about this? 12 is LCM, 4 3s are 3 plus 1 4. My answer will be ml square by 3. So what's the moment of inertia about one end, students? ml square by 3. What did I use? I used parallel axis theorem, students. क्या ये clear हुआ, students?
Yes, sir.
Yes, sir.
Can I erase both these, students?
Sir, wait.
Yes.
Sir, in the parallel axis diagram,
Hmm.
what have you written under height, the thing below?
It's mass capital M. Mass capital M. Because I'm using capital M as a mass of the body.
Sir, don't.
John, shall I erase it?
Yes, sir.
Yes.
Okay. Now, students, your last part. Last part speaks about your rotational rolling kinetic energy, students. And the motion is rolling. So call as your rolling motion, students. Since rolling motion of a rigid body is actually, it's a summation of translational plus rotational. Translational motion plus rotational motion, a combination of the two, students. Rolling simply we consider as what, students? It's a translational plus rotational. A combination of these two we consider as called as what? Rolling motion, students. We are trying to get a mathematical relation for this. Now listen carefully, students. To get this, let us say that a body is made to roll down an inclined plane. And the plane is placed at an angle theta with the horizontal, students. Let us say this is the height of the plane. Point A is the point where the body is set to roll down. The ball or the object is initially at rest. So it has translational motion as well as it will have rotational motion, students. The two motions. And its initial velocity is 0. It is rolling down an inclined plane. Let us say that the body is undergoing a displacement S down the inclined plane. This is point A, this is point B, and this is point C. This is what the ground I'll consider. Now, when you look into it, students, when I make a body to roll down an inclined plane, students, we need to go for translation motion plus rotational. I want an equation for rolling motion. What exactly rolling motion, students? When I go for translation motion, students, can you tell me what's the formula for translation motion for such a body? Then your answer will be, sir, it's half mv square. What about the formula for rotational motion for such a body? Then what do you say? It's half I omega square. Are these two relations clear? This becomes my kinetic energy rolling. So whenever you go for kinetic energy rolling, students, it will be translational plus rotational. क्या ये clear हुआ, students?
Yes,
Yes,
sir.
sir.
Now when I rewrite it, it's half mv square plus half. Instead of I, students, instead of I, can I write a moment of inertia in terms of radius of gyration? So instead of I, can I write this as mk square? है? What is radius of gyration, students? What is the definition of radius of gyration? Radius of gyration is a distance of a point mass for a given body with the entire mass of the body supposed to be concentrated, and it has a moment of inertia equal to the moment of inertia of that body. So I can rewrite, अगर suppose मैं ये कोई object लेता हूँ, let us say a disk or a sphere or a cylinder, okay, or a ring is made to roll down an inclined plane. So what is the moment of inertia of that particular body is equal to mk square. I can write on this instead of I can write on mk square. Likewise, what exactly omega can be written as? So students, I'm using I is equal to mk square as one relation, and second I'm using V is equal to R omega because the body is undergoing translation also. So now instead of omega, students, can I put V square by R square over here substituting omega? क्या ये clear हुआ सबको?
Yes, sir.
This is very important relation. Why am I giving you? See, one can use these two relations and can solve problems. Can solve problems. लेकिन students, अगर तुम ध्यान से देखोगे, अभी तुम्हारा expression देखोगे ना, तो बोले सर, हाँ सर, आपने कुछ common निकाल दिया यहाँ पे, क्योंकि आपने जैसे I को substitute किया, ओमेगा को substitute किया, तो यहाँ पे मेरा half mv square बाहर आ गया. बच्चा क्या रूट के अंदर? सर बच्चा क्या ब्रैकेट के अंदर? It's 1 plus k square by r square. Now, why did I give you this as an expression? Why not I made you to keep this only? The reason, students, because you have given the value of k square by r square for all spherical objects, almost all geometrical shape objects. कुछ याद आ रहा है, students? अगर मैंने रिंग लिया, ध्यान से सुना, रिंग लिया, इसका मोमेंट ऑफ इनर्शिया क्या था? mr square. अगर यही रिंग को मैं एक पॉइंट मास लेता हूँ और उसका डिस्टेंस मैं k लेता हूँ, mass is m, so can I put it as equal to mk square? So what exactly k square by r square for a ring I'm getting it is equal to 1. Students, यहाँ पे हमने radius of gyration के बारे में पढ़ा था और यहाँ पे मैंने k square by r square की value दी. It is for ring, and this I'm going to use it back over here. This makes my calculations much more easier. This makes my MCQs much more easier. उससे मुझे पता चल जाएगा कि कौन सा ऑब्जेक्ट है. को डायरेक्टली अगर मैं k square की r square की वैल्यू डाल दूं तो 1 + 1 will be 2, 2 and 2 will get cancelled. Answer is mv, mass of that particular body, and the linear velocity I can consider. क्या ये relation clear हुआ, students? This is kinetic energy rolling, and this answer would be in Joule. Is this clear to all of you, students?
So that k square by
Yes,
r
sir.
square will be already given, right? Or we need to-
But you can, and you can find out if it's not given. Suppose if in case if I give you a solid sphere, come on, can you give me the value of a solid sphere, k square by r square for a solid sphere? So how do you get it? You should know the moment of inertia passing. What is the moment of inertia for a solid sphere? 2/5
2 by
r
5.
square. Can I write down equal to mk square? Why not? Mass gets cancelled. So what's the value of k square by r square for a solid sphere? 2/5. So 1 plus 2/5, 7/5. You can get your answer for rolling kinetic energy.
Yes, understood.
यानी जरूरी नहीं कि k square by r square देंगे. You can find out for geometrical shape bodies. यानी तुम्हें moment of inertia जिसका पता है, simply उसको लिख देना equal to mk square. ओ यानी सर, हमें सबके मोमेंट ऑफ इनर्शिया थर्ली याद होगा तो ही हम इसको क्रैक कर सकते हैं. तो भाई जब यहाँ पे तुम्हें मोमेंट ऑफ इनर्शिया की जरूरत गिरेगी तो यहाँ पे भी तो गिर रही है ना. यहाँ पे भी तो तुम्हें आई की वैल्यू तुम्हें पता होनी चाहिए ना, तो ही तुम आगे बढ़ोगे, नहीं तो नहीं बढ़ सकते हो. लेकिन यहाँ पे याद होने से तुम्हारा कैलकुलेशन इजी हो जाता है। देखो या तो तुम यहाँ आई निकालो, फिर वापस ओमेगा निकालो, फिर उसको मल्टीप्लाई करके गेट एन आंसर, फिर उसके साथ में इसको ऐड करो, सो दिस बिकम्स मोर फास्टर एंड दिस बिकम्स इजी फॉर कंपैरिजन आल्सो। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Now suppose if I ask you students, can you give me with what velocity, students, with what velocity the body can reach at the bottom? Suppose the same body moves and it reaches at the bottom. Can you find out the velocity with which it can reach at the bottom? That is at point C. I want to find out that. So now students have done laws of motion also. I'm getting it. The next part you will be going for work energy part. तो यहाँ पे हम वर्क एनर्जी पार्ट के कंसेप्ट यूज कर सकते हैं। मैंने क्या पूछा, अगर तुमने बॉडी को यहाँ से रिलीज किया, इसकी इनिशियल वेलोसिटी 0 है, यहाँ पे आएगा तो क्या उसकी वेलोसिटी होगी? तुरंत तुम्हारा ध्यान जाना चाहिए लॉ ऑफ कंजर्वेशन ऑफ मैकेनिकल एनर्जी। That is which one? Rotational. What exactly the total energy over here? So total energy over here I'll consider equal to what? We consider is equal to the potential energy plus the kinetic energy we consider in this case. I getting it? Total energy यहाँ पे क्या है? So energy total at point A, agree students, is equal to total energy at point C. What is total energy at point A? So it's potential energy at point A plus kinetic energy at point A. What is total energy at point C? It will be only kinetic energy at point C. But which energy at point C? Which kinetic energy? क्योंकि यहाँ पे potential energy होगा नहीं. It's ground level. यहाँ पे तो potential energy होगा नहीं. At point C कौन सी energy? Kinetic कौन सी? Translational, rotational या rolling? तो तुम्हारा आंसर होना चाहिए सर rolling होगा ना, क्योंकि बॉडी रोल होते हुए आया। कुछ समझ में आ रहा है? I'm using law of conservation of mechanical energy. Total energy at point A is equal to total energy at point C. What is kinetic energy at point A? So वो तो zero होगा क्योंकि initial velocity zero. ये तो zero आएगा. What is potential energy? Mass of the body, gravitational acceleration, and its position that will be given to you, which is equal to, what's the formula for rolling kinetic energy? Half m v square 1 plus k square by r square. Can I cancel m? Yes. Can I get the formula for v square? 2g h upon 1 plus k square by r square. What is v? Within the root sign. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Yes, sir.
यहाँ पे इसकी जरूरत होगी, अभी ये तुम्हारे लिए बहुत हेल्प करेगा। Students, now suppose if I give you a question an MCQ which is slightly on the tricky side, which most of the students find out tricky. If I give you a uniform ring, a uniform disk, students, a uniform ring, a uniform disk, a uniform sphere, all these three of same mass, all of these of same mass are made to be released at the same height on an inclined plane, students, in that case. Can you find out which one can reach first over here? कौन सबसे पहला पहुंचेगा? सबसे पहले कौन पहुंचेगा? जिसकी सबसे वेलोसिटी ज्यादा होगी। तीन ऑब्जेक्ट आपने दिए, रिंग, डिस्क, स्फीयर, सॉलिड स्फीयर, तीनों का मास सेम है। अच्छा, मास तो होगा ही नहीं सर। अगर मैं वेलोसिटी का फॉर्मूला लूं तो सबको आपने सेम पोजीशन से छोड़ा है, तो हाउ इज वेलोसिटी? इनवर्सली प्रोपोर्शनल टू 1 प्लस k स्क्वायर बाय r स्क्वायर। स्टूडेंट्स, यानी तुम्हें करना क्या है? तुम्हें करना क्या है? सिर्फ रिंग का वैल्यू k स्क्वायर बाय r स्क्वायर डालना है, क्रॉस चेक करना है, फिर डिस्क का k स्क्वायर बाय r स्क्वायर डालना है और स्फीयर का डालना है। स्टूडेंट्स, जिसका डिनोमिनेटर की वैल्यू कम, उसकी वेलोसिटी ज्यादा। इनवर्स वेरिएशन है ना, बाकी ये तो कांस्टेंट है, यानी v इज इनवर्सली प्रोपोर्शनल टू व्हाट? 1 प्लस k स्क्वायर बाय r स्क्वायर। अगर तुम k स्क्वायर बाय r स्क्वायर रिंग की डाल दो, स्फीयर की डाल दो, डिस्क की डाल दो और फिर उसको सिर्फ रूट में रखो ना, थोड़ा सा मेंटली कैलकुलेशन करके एक आंसर निकालो। अगर तुम्हारा आंसर 1.5 आता है किसी का, फिर 2.5 आता है, तो 1.5 इज स्मॉलर एज कंपेयर टू, तो उसकी वेलोसिटी ज्यादा होगी। तो यू कैन कम टू कंक्लूजन हु रीचेस फर्स्ट। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
That is why k square by r square. So try to remember your mathematical relation in this case. Now a student will say, sir, velocity निकाल दिया, तो sir can I find out displacement also? Can I find out acceleration also? क्यों नहीं? सारे linear kinematics use कर दो, सारे linear kinematics use कर दो, क्यों नहीं मिल सकता तुम्हें? You can get it. If I try to go for acceleration also, you can get it. V square is equal to U square plus 2s. Students, I can use that formula. V का formula मेरे हाथ में है. Initial तो 0 है. Displacement s. Can I get the value for a? Why not? तो मैं acceleration मिल जाएगा. Can I take the time for it to move down? Why not? V is equal to U plus 80. Students, are you getting it? You can get different relations for going for linear kinematics. So a body when made to move down an inclined plane, students, okay, it will have translational motion as well as rotational. Now the very important statement. ये जो translational और ये जो rotational दोनों कभी possible होता है मालूम है students? Of course, body जब भी roll होगा, लेकिन rolling के लिए students, the surface should offer friction. यानी अगर मेरा surface irregular होगा, तो rolling होगा. अभी ध्यान से सुनना, ये मैंने inclined plane लिया, ध्यान से सुनना students. अगर इसी के ऊपर मैंने oil डाल दिया, students, if it's oil, I getting it? Then in that case, will the body will rotate or will just slide?
Slide.
So what kind of motion? Are you getting, students? That is only when you get questions of these kinds down the inclined plane, read the question very carefully. Are they speaking about a body sliding down an inclined plane? When they use the word sliding, or there is no friction in that case, then it's simply sliding. Or when oil is put onto it, or when the surface is wet, the coefficient of friction has been reduced to a great extent. तो होगा क्या? Body slide करेगा. लेकिन जब भी friction है वहां पे, तो it will have translational as well as rotational. So rolling motion, students, is always considered due to presence of friction. When there is no friction, the body will simply skid, S-K-I-D, or slide. That is translation motion. Is that clear, students?
Yes, sir.
That is the end of your chapter, students. Okay.
Okay,
Hope
sir.
you understand, okay. So students, next lecture, whatever topic will be there, if in case of any of your topic related to both, okay, we'll continue further. Right? Okay, students.
Yes, sir.
Sure.
Okay,
Good
sir,
night.
thank you.
Okay. Bye.
Thank you, sir. Bye, sir.
Bye, sir. Thank you, sir.
Thank you, sir. Bye, sir.
Okay.
Bye.